Welcome to Brain Vision.
To find all the quantum numbers from the 3D subshell, we're going to first consider the fact that the number here that's given is the n value. So n is equal to 3 in this situation. And L, the spin angular momentum quantum number, is equal to 2. This comes from, or excuse me, is equal to 2. This comes directly from the fact that it's the D subshell. This is because S is equal to 0, P is equal to 1, D is equal to 2, F is equal to 3. Now, based on the fact that L is equal to 2, we can get our M sub L value. So M sub L is equal to negative L, from negative L to L. Therefore, we have M sub L is equal to negative 2 all the way to 2. So our values, of course, since they can only take on integer values, are plus or minus 2, because it can go from negative 2 to 2, plus or minus 1, and 0. So that covers all the values from negative 2 to 2. So we can box that in as part of our solution. This is also part of our solution. And the last one are the spin quantum numbers, M sub s. Since we're dealing with electrons, they can only have spin of up or spin down. So plus or minus 1/2, spin up or spin down, since it's an electron. Now for part B, we're going to do the same thing for the 3p subshell. Well, again, right away, since it's 3, we know n is equal to 3. And P, as we mentioned, is equal to 1. So S is equal to 0, P is equal to 1. So this means that L is equal to 1 based on the P value. M sub L, since again, it's from negative L to positive L, goes from negative 1 to positive 1 by integers. So the only values it can take on are plus or minus 1 or 0. We can box that in. Oh, and actually, let's do our last one, the spin. Again, we're dealing with electrons. So M sub F can only be plus or minus 1/2 for the up or down spin of an electron. We can box this in as the solution for part B. And that's the final part of our question.